Hi, in this video we are going to be exploring the concept of true or false. Okay, so in C or C++, we have this variable, okay, or data type known as bool or boolean. Okay, so what is boolean? Okay, so when we talk about boolean, we are talking about logic, okay, logical values, and in logical values we say there is either 0 or 1, and that translates to either being true for 1 and false for 0. Okay, so it's either 1 or 0, true or false. Alright, so when you declare a variable as bool or boolean, alright, you can assign it to either true or false. So this is available in C++. So let's do this over here in the code. So if I declare a variable bool and I call this flag, okay, I can assign flag to a value, let's say true. Okay, or maybe I'll just do it together in the same line over here. Okay, and if I print out, if I do a if else check here, if flag, okay, true, else false. Okay, so with this, if I run the code, it will print out as true. Okay, and if I replace here with false, if I update the flag to be false, then it will print out as false. All right, so basically this also brings us to another concept, which is the checking of the if or if else conditions. Okay, basically what we are trying to check when we write a series of if and if else statements. Okay, so if something, okay, if some condition is true, I do something, else I do something else. Alright, so here whatever expression that I am putting here, I'm effectively trying to check whether the condition is true or false. So when you say it is true or false, that translates to 1 or 0. Alright, now if I were to, for example, put an expression here, okay, so instead of bool, okay, so let me replace this with an integer. So I say integer x, okay, and I put it a value of 32, and I check whether x is greater than 25. Alright, so in this case, I'm trying to print out, I'm trying to check whether this condition x is greater than 25. If it is true, then I print out the first line, which is true. Okay, if not, I print out false. Okay, so if I run the code here, we see that the true is printed out because we know that 32 is greater than 25. Okay, now what does this check actually give us? Alright, so as we saw just now, whatever that I put inside my if check is actually translating to true or false, which is 1 or 0. Okay, which means that if here I am going to print out this check of 32 check of x, okay, is alright, and what I'm going to do is I'm actually going to print out this comparison x greater than 25 here. Okay, so what I'm trying to do is I want to see what is the evaluation outcome when I do this comparison of x greater than 25. Okay, so if I run the code now, okay, we see that this outcome is 1. Okay, this outcome is 1. Alright, why? Because when I compare 32 with 25, the outcome is true. So logically, true translates to a 1. Okay, now instead of comparing, okay, what if I just put a numerical value here, x? Then what will I print out? Will it be true or will it be false? Okay, so here I'm not doing any check. I'm not checking whether x is greater than any number, smaller than or equal to any particular value. I'm just checking and saying if x, and x is now assigned a value of 32. Alright, and if I run it, it will say true. Okay, what if I put in a negative number, 99? For example, negative 99. It also says true. Okay, so positive number also says true, negative number also says true. So what is false? Okay, so the only value that will be false will be 0. Okay, only if it is 0, it is false. Okay, so of course you may be thinking why is this the case? Because if I'm just checking for a numerical value, if I just put a value here, okay, if I just put a value here, x, alright, I am checking effectively what is the binary representation of x. Okay, and of course this leads to another bigger topic, which is number representation, positive, negative, 2's complement, and so on. Okay, but without going into all of that, all I can say is any number, okay, is when you look at the binary representation, whether it's 8-bit, 16-bit, or 32-bit. Okay, so let's just for simplicity's sake stick with the 8-bit number. So for 8-bit number, we know that the range of the numbers is from 0, 0, 0, 0, 0, 0, 0, 0, all the way to 1, 1, 1, 1, 1, 1, 1, 1. Okay, now effectively all the numbers after 0 will have at least one of the 8 bits with a value of 1. Okay, and the only number where all the bits will be 0 is 0. Alright, so only when all the bits are 0, then we say it is false. Okay, it equates to logic 0. As long as any of the other bits is a 1, okay, regardless whether it's 8-bit, 16-bit, 32-bit, or 64-bit, okay, as long as any of the other bits is a 1, okay, it will be classified as true. Okay, it will be classified as true. So that is why, okay, in the code, okay, only 0 gives me a false. Any other number, okay, even if I put a float number, okay, even if I put a float and I put 99.9, okay, it will still classify as a true. Okay, so that is the idea behind true and false and how it is being evaluated in a if-else statement. Okay, so I hope this concept of true and false is clear right now. Okay, so thank you for watching. I'll see you in my next video. Bye.